Welcome you all. My name is Vetrivel, Assistant Professor in Artificial Intelligence and Data Science Department at Ramco Institute of Technology. In this session, we discuss about fire severity and how it is compared between component fire and furnace fire. This topic is used to understand the equivalence and evaluate how the structure behave in real fire and lab fire tests. The slide shows the classic fire triangle. This is three main components of fire. First one is heat, second one is fuel, third one is oxygen. And if you remove any component, the fire will be distinguished and it's not spread over the building or room. The first components of the fire is heat, and its heat would came from spark, friction, and electrical equipment lightning or any other source. The primary function of the heat is to rise the material to and increase the temperature and enabling to it burn. The second essential component of fire is fuel. It may be a material, solid, liquid or gas. The common examples for the fuel is wood, fiber, paper, plastic, natural gas, glycerin. It may be any combustible materials. Okay, it provides the material that burns and sustain the fires. It supports for the material. The third component is oxygen. It is usually available in 20% of air. It supports the acceleration process required for the combustion, and without the acceleration process, the fire can't be continued. This is why controlling the ventilation in fire accident is major plays. It plays the major role of growth and intensity of the fire. Fire severity refers to the thermal exposure experienced by the structural elements or material over the time. In simple terms, it is temperature multiplied by the duration. The temperature which is multiplied by the duration is known as fire severity. It is helped to find or evaluate how the building materials will be performed under the fire, and it's widely used for structural fire engineering. Let me compare the fire severity between component fire and furnace fire. Let me move into the component fire. This component fire occurs within the enclosed room or space. Its behaviors depends upon three major factors. First one is ventilation of the room, whether the room is enclosed or which have any open space. Second one is fuel load, whether the room have any fuel materials like paper, wood, plastic or not. Third one is geometry of the room. This component fire has three phases. First one is growth phase, second one is post flashover phase, the third one is decay phase. Unlike the standard test, fire, the component fire do not allow fixed temperature curve. This temperature distribution is uneven and changed dynamically. Compared with furnace fire or standard fire test, which is taken in any laboratory or institution. After the component fire, we move into the furnace fire. The furnace fire refers to controlled laboratory fire test such as ISO 834. Here the temperature follows the predefined time temperature curve. Temperature rise continuously with no decay phase. There is no decay phase in component fire. We have three phases. First one is growth, second one is post flashover, third one is decay phase. But in furnace fire, there is no decay phase. The furnace environment provide uniform heat and allowing the consistent comparisons of materials and systems. The purpose of the fire severity equivalence is to match the thermal explosions of real component fire and standard furnace fire. This is done by comparing the area under their temperature time curves. The goal is to achieve the laboratory testing reflects the real world fire behavior. These are the methods used for evaluating the component fire and furnace fire. First method is equivalent fire distribution, and the time equivalent method graph comparison damaged based comparisons. This method is used to achieve or ensure the laboratory testing reflects the real world fire behavior or not. Let's see the quick comparison between the component fire and the furnace fire. The expert is environment real world scenario. In furnace fire, here the lab standard testing methods are followed. Second one is component fire have three phases of fire. Here there is no phases in fire. Okay, and the temperature is ununiform in component fire. There is a uniform temperature time curve is present in furnace fire. Okay, there is a time temperature curve is irregular. Here is standard. The ISO standard number is 834. Okay, the comparison method was time PhD equivalence in component fire area or graph or in conclude, the component fire shows the realistic and unpredictable temperature behavior, whereas furnace fire offers the controlled standard method for testing the structural elements. Fire severity equivalence bridge the gap and ensuring the performance-based fire design can rely on accurate and meaningful testing. Thank you.